Hi, everyone. I assume it's 3:10, so let's get started. It's a little bit moving, so. Hi, my name is Katrin Shechtman, and I work for Lightbend. And the topic of my talk today is actually microservices and checklists. It's a little bit different from what you saw online, but I mean, it's practically the same, it's just shorter. So we are going to talk why microservices are overhyped and why it's not true and how to overcome it. So let's see. Before we continue, I probably need to create some kind of trust here, some kind of credibility. So let's see what my relevant background is in this area. So in 2003-04, during my master's, I've done some distributed system or distributed computing kind of thing. I've actually tried to create distributed MATLAB. And it was a little bit way before embarrassingly parallel algorithms got their rebranding and started being called MapReduce. There was also a time of OpenMP and MPI. Everyone who knows that it shows their age. So, but it was way before all the tools and all the goodness that we have today. So fast forward to 2006, 2012, industry took its toll. I had to learn how to speak J2E and how to speak Spring. It was not easy. Spring I liked after I had to learn J2E, but then in 2000, and also I've done some distributed computing software that got acquired by IBM, so it's probably that's why I'm trying to forget it even though I put it on a slide. Fast forward in 2012. So first I've learned what the play is, the play framework I mean. Then I was introduced to Scala, and then Akka came along in this order. And I was feeling that I'm living in a dream. Now, so around 2015, 2016 timeframes, microservices came under my radar. And actually, it a little bit broke my dream because when I first was introduced to the notion of microservices, when I first started thinking about it or heard from clients about microservices, I was under my very academic impression that microservices are actually a private case of distributed system. So nothing really new. And the idea of microservices actually, it's pretty simple. Instead of going and implementing some custom distributed system with their own demands, we're actually talking about systems that first, they really need scalability. They are tolerant a little bit to some latency, and they're in total need of some polyglot components. That's what I thought. I was still living a dream. But then I became an enterprise architect. It was a mistake of my life because now when I hear clients and when I read the internet, the first thing that I'm trying to notice, or the first thing that comes to my mind when I do my research, which more or less became my life coding these days, I've noticed things that there's a lot of misperception going on over the internet and in the minds of the clients that I'm meeting. So suggestions like develop monolith as long as you can. Sounds like you can switch from monolith to have your microservices, which is distributed system after all, by kind of configuration magic, which is, I don't know, maybe it's doable, but it sounds like something that cannot be done. And also, there's a lot of clients that I've met, they're expecting different results while still doing exactly the same with exact same technologies. Sometimes those technologies are actually kind of repackaged, but at times they even are not so. So it's exactly the same technologies, it's exactly the same approach, and still the expectation for result is different, and with this expectation comes disappointment. So no further ado, let's try to see why it happens and what can be done in space. So let's talk about imaginary e-commerce. My imaginary e-commerce will be clone of Walmart, for example. So I prefer to go to Walmart rather than Amazon because first of all, I'm from Canada and it's walmart.ca. And second, Walmart actually uses Akka and play under the hood. So from technical point of view, I'm sure that it's going to be great, right? It's going to be, sorry about that it's going to be fast. But right now, I'm changing my heads from going to be fast to someone who tries to build their microservice for the first time, and they're trying to build the clone of e-commerce site. Okay, so here, for example, if I want to do search, right, I have an option to shop for some things, or I have an option to search through all the departments. So, for example, if I'm interested in everything green, for whatever it was, there's a lot of green things. They're very different, but it gave me results, right? It gave me pills, it gave me some kid toys, whatever, right? Okay, so let's see. So I want my functionality to resemble what we've just seen with the same kind of latency. Now, I still don't know what the microservices are. I only want e-commerce site, and I want my perfect server. So by the technologies that I already know and I already love, that's how it works, right? I'm going and I'm creating my perfect big hairy server with some DI dependencies that always come to the same resolution. I have some GPA in place that I so love. It's less than ideal performance, but I know how it works. I know all the pitfalls. I know how to get around them. Okay, it's only 5% of CPU utilization because of the thread model, but that's fine. It's a perfect as it is, because I know it, I love it, and I'm not ready yet to switch to something that I'm scared of. Now, it's indeed perfect, but the only problem that when load increases, when load of year 2016 comes in, my server will continue to very fairly serve the customers, and it won't pay attention whether some customer trying to pay for its cards that they created, or there are some other customers that will try to search. So it doesn't matter, right? Pay right after in the same line for search clients. It means that I probably want to scale it out, right? Horizontal scaling, everyone knows what it is. With GE, continuous GV service, it's quite interesting idea. You don't exactly get a horizontal scaling because you have sticky sessions, but you can try, right? You can kind of fool yourself into notion of reading documentation or not reading it actually, because when you read it, you understand that it's not cluster, but whatever, right? Now, once you're scaling it out and you're going to cloud because it's 2016, you're going to make someone happy. It might be one of these guys, right? But it's not going to be your dad or your CEO because the cost efficiency of this solution is just skyrocketing, right? So who knows? Well, everyone knows who's on the left. It's on the right for you, actually. Okay, the bigger picture. Let's go by this. Who's on the bigger picture? Jeff, exactly. Who's on the left? Younger generation. Okay. Actually, I had to search. So I remembered the Dell, its last name Dell, but I didn't remember what's the name. So at least it makes me a little bit younger. So it's Michael Dell. Okay. So what I'm trying to convey here, you either going to deploy your horizontal scaling as it costs a small or big fortune on premises or on cloud. This or that, you're going to pay a lot of money. Now, so probably you want to search for something else for 2016, and you're probably going to search it online. The first thing that you do, okay, the first thing that I do when I go to search online, first of all, I check a couple of first links, and if it doesn't give me an answer, I go to people whom I trust. So everyone trusts Martin Fowler. I'm going to him, and I'm reading his articles. One of the articles says me microservices. I'm start reading it, and I'm getting two things. So I'm getting to the short notion of what microservices are. So it's an approach. We're developing single application, small services. So each one of them its own process, and it's probably will communicate through HTTP resource API. Okay, so far so good. I can take it. I know how to deploy small processes. Each one of them talks to each other by HTTP. Okay, so far so good. Okay, so it's actually built around business capabilities. Okay, it's not, instead of the project, I have to build it around product. Okay, so far so good. Bare minimum of centralized management, fine. Oh, maybe written different programming, I like it. Because now I can hire anyone I want. It could be Python, it could be C++. I can throw some Ruby in place, just, just to make it more interesting. If I stumbled upon some humble Scala developers that doesn't know how much he costs right now, I will bring him in as well. So it will be fine. And also, oh my God, I can use different data storage technologies. Well, I probably will use Oracle because it will give me not the best performance, but the best consistency. I will be sure that if my shopping cart in good hands of Oracle and not someone else, like who is Cassandra? Really? What will happen if it fails? Okay, so microservices to the rescue. Okay, microservices to the rescue. So we have in our very small e-commerce site, we have shopping cart and search. So each one of them is going to be a service, right? Also, as we've seen, there's a lot of departments. So for example, in Amazon, the last time that I checked, that it was yesterday, there was 36 departments. So I'm gonna divide the different departments into services as well. I'm not gonna care about the language to use. Personally speaking, it's only for the sake of this talk. But back on my head, I don't care about the languages. I care about architecture right now. So, perfect microservices. What we see here answers everything that Martin Fuller's put it in a short description. We have a website, and we have all the microservices. Each department, microservice per each department. We are searching for books, for example, in books microservice, we're searching for kitchen and dining in kitchen and dining microservice, and so on and so forth. Before we continue, you'll tell me, oh, what kind of example it is. Of course, search should be replicated to some other database and should be indexed and searched from it. I'm under NDA with so many clients. If I put any reasonable solution here, I will be sued by one of them. So I brought the examples that no possible client will say we have this in our house. Unless it's really, they have to change it anyways. So bear with me with this example, okay? So we have books, kitchen and dining, blah, 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 and microservices, right? Is it perfect solution? It answers everything. It's in each own process. They talk to each other by HTTP. Probably I even was not lazy. I put API gateway. So the website doesn't have to go to 10,000 microservices at once. Is it perfect or not? Can we go home? Okay, we didn't ask ourselves very simple question. How long does this search take? And the answer is probably, it depends, right? In the worst case, by seeing the numbers, if it's going one, but then if it's going to search in books, and then it's going to search in kitchen, and then it's going to search in sports and outdoors at some point in the time, it will be 100 millis, but actually multiplied by number of services, right? Now, it's not made up, because if you do use some of the frameworks or some of the tools, the existing tools, as I mentioned before, you are actually encouraged to use this way, because there is no utilities that enable you to do it other ways. We will talk about them in a sec. So it's probably not perfect. Okay, so it is less than perfect microservices, but you know what? I'm gonna get by it for so far, because 3 seconds or 4 seconds, whatever, for 36 departments, something that I can tolerate still. But then maybe one of the microservices just has an error, right? And it takes 2 seconds just to reboot themselves, right? To handle this fault, this error. So kitchen and dining is going to answer this request in 2 seconds. So how about the same question? It's exactly the same architecture, answers the short description of what we know usually on the internet. How long does this search take? So it's 100 millis by number of healthy services plus unhealthy service number 1, its time, unhealthy service number 2, its time, and so on and so forth. So once we have any error, it becomes actually, it's not something that we can tolerate. By the time that we have this answer, there is no user to give this answer to. They are long gone from Walmart somewhere else, probably to Amazon. But in our case, it's not going to be like this. So, did microservices fail? Did this approach fail? Do I need to search for something else, or to come back and say, okay, Oracle representatives were right when they told me that I need to use ATG? Well, the answer is actually lies in technology, right? It lies in science. So what we forgot to mention, or what we didn't pay attention when we implemented this solution, we didn't think about multi-threading. We didn't think about synchronous versus asynchronous I/O, right? So once we have, for example, asynchronous I/O, and we have multiple threads because we have multiple cores, all of a sudden, instead of having such a bad performance, which is totally not scalable and not in actually linear almost per number of services, we can get a pretty good performance. So the answer is actually lies in detail. The microservices didn't fail. We just did it wrong. We were supposed to do it differently. And to do it right, it means to send every request to each of the microservices in parallel, right? In this case, even if you don't have asynchronous I/O, you could get away probably partially with wrapping your calls by kind of futures to make it a little bit more performant than now. But anyways, if you have asynchronous I/O, even better. If you have multi-core with multi-threads, even better. It means the throughput just got better. So it's about how we create microservices, rather than how the notion of microservices. So far, there is no flaw that we found in the microservices approach. There is a flaw how we implemented it. So there's a little quiz for you. So how long does the search take now? Let's see who is not asleep yet. Okay. 200, 300, 400, and 100, yeah, thank you. I know, I pulled it off. I have another one that probably with you it will be harder, but we'll see. Okay, so microservices. So right now, as we see in this diagram, we do our asynchronous requests. So we still have kind of 100 milliseconds for every request. But now we added a new service, because before that, we had only search. Right now, we also have a shopping cart, right? And this time, we added the notion of database. Before there was database, we just didn't show what the implementation details of it. Now we have it, and everything here actually goes to the same database. So within one database, big, nice, centralized database with some good replication between data centers, takes only 5 minutes, not such a bad thing. Everything in one database. Are those microservices perfect? Why they're not perfect? It's because we just created the distributed monolith. It doesn't matter where the code runs, you can scale it very good, but it doesn't matter because you have point of contention, right? So as long as the isolation of components that we try to achieve when we created microservices is not full, it doesn't matter. You are as slow as the slowest point of your system. And you know, when the team comes in and they say, we have a perfect Akka-based system. It's just perfect. It feels good when I see the code, but then when it's being deployed, we have this Oracle that doesn't perform. Oracle will gonna kill me. But I do have clients, so maybe I will be able to use it as a disclosure in my court hearing. So as long as it goes to the same database, even the big one, even very performant one, it won't hold because we are living in 2016. Now, so what the problem is? The problem is with all the examples that I gave now, and there are more and more, right? We can run it for a couple of hours at least. The problem is in short definitions. The short definitions won't suffice. And short definitions are very, very risky and they're poisonous because as later we will see during the talk, when you have this point of decision what kind of tools to choose or what kind of architecture, the physical, the more detailed architecture to do, you can't go only by short definition and hope for good. Because anything like all the buzzwords like cloud, change cycles, scaling, those are not the goal. When you come to your product manager or you come to CEO and you say, oh, I have perfect scalability, they would say, really? But how are users, how they are feeling, right? So it's not only a goal, it's also not a complete list. And we probably need a complete list to make it work, as we've seen. So the goal is actually, technically speaking, right? Responsiveness. We want our system to be responsive. So we can't come and say our architecture is perfect, as long as we don't have in our mind responsiveness as a goal. Now, resilience, capability, and continuous delivery, those are pillars for creating good distributed system and microservices, distributed system in general and microservices particular. But those are core design principles. Once again, the problem is its ambiguity, and the problem is the short notions. So once, something that I tweeted this morning, and I don't know if it will resonate with you, as I was kind of going over my talk once again, once the devil was in details. You remember those days, oh, the devil is in details, like around 2007, and now it's unambiguous definitions. So the time have changed, and we need to adjust ourselves accordingly. Now, those are core design principles. Those are umbrella for more nested principles, and we need them all. And we need this checklist of those principles that we can check the architecture that we are creating against it all the time, with every component that we bring into the system, with any components that we either write or third-party software or third-party things that we bring into the system. Because if they won't hold the water, your system won't hold as well. Skipping over any of those principles that we are going to talk in a sec isn't an option. If you skip on even one of them, you're gonna get, I could say unpredictable results, but actually they're pretty predictable. It's gonna fail at some point in time, and it's gonna crash hard. So what are the principles? Continuous delivery. Let's talk about continuous delivery. So it's very broad notion, and people would come and argue, but we don't need continuous delivery because we have our releases once in a while. But when we are talking about continuous delivery, it's not about how fast even, or how frequently you're delivering your software. It's more about what kind of automation you have in place and what kind of velocity your teams have. Okay, that's the idea. Now, the goal of continuous delivery, once again, continuous delivery, it's not a goal. Goal is velocity of your team. And I decided to start with continuous delivery because one of the principles of continuous delivery hurts. It hurts me, and it's gonna hurt you. Code isolation. So let's repeat it. And that's one interesting, I'm gonna pull it off with you. We don't share our code. We don't have shared libraries. So let's just do. We don't share our code. It's very hard. It's very hard. Not either the code, nor the libraries, almost, very specifically, but always versioned. So once again, code isolation hurts. It hurts everyone who is above kind of age 12. And the idea is probably because in kindergarten we were taught, oh, you need to share, right? But now, don't. And that's the idea. It's very hard. I was in the client meeting with some enterprise architect with a very big bank, and it went quite well. And I was very happy with the results. And then I came to the point of code isolation. That's where our relationship deteriorated. Like it went south right away. It was very hard. It's very hard to get. I know that I'm talking about it 5 minutes. This one, it's actually the hardest. Now, independent deployment. This one we actually like, because it means that if I have a team and we want to deploy the specific component and I'm responsible for this component, I'm not blocked on anyone, right? Not other teams, nor some code that was deployed together with mine. Independent deployment makes me feel better because at any given point in time, I just can deploy what I've done. DevOps. And DevOps, it actually became a principle. Once it's actually virtual didn't exist. After that, it became dedicated team. Then we started supported it, and now we are DevOps themselves. We are DevOps ourselves. That's how it works. And DevOps, it's so grained when you need to do microservices that you can't get away with by it. You have to have DevOps, and you have at least support or do it yourself. Now, scalability. This one rather a little bit, it's not too vague, but it's very broad notion, and even people in my close circle who are breathing and talking about, let's speak about this architecture, and let's speak about scalability, and let's speak about elasticity, all of a sudden I can get two different slides from two different people. It's exactly the same. On one of them there will be scalable and another one elastic. Is it the same? I don't know, we'll see. I mean, I do, because I checked the definition. But the idea is that scalability, it means when load increases, your system can increase with its load. And that's it. No more, no less. Okay? Now, the goal is responsiveness. Why responsiveness? Because once there is more load, we want to maintain the same latency, we would add components to the system. First of all, and it's a really important point, does it make sense to have 10,000 servers which were scaled and added dynamically when each one of them has 10% of CPU utilization? It doesn't, right? It sounds as silly as it is. Now, it means that any scalability starts with CPU utilization. It starts with scalability multi-cores before we go into this notion of nodes and containers and virtual servers and then cloud providers and what's not. There's a long way ahead of us, but CPU utilization, it starts there. So any framework or anything that claims to be scalable but doesn't utilize the CPU efficiently, I don't know, it's your call. Componentization. Okay, so this one, once again, we kind of talked before that. We want to have our capabilities organized around business capabilities rather than projects, right? Now, there is a funny fact. If you're going to Google and you're searching for componentization, let's see what it does. Turns out to be that it's seductive. So please be warned, okay? I don't have any liability if you're becoming seducted to componentization, okay? It is practice, blah, 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 but this one rather is really interesting. I don't know why. Found it peculiar. Anyway, so as I said, disclaimer is there on the slides. Now, since you're, it's written, it's a little bit hard to cope probably afternoon with such big speakers, and then I come, my credibility is question what and what. Who knows what AR and BC in the context of componentization is? Okay. 3 letters, same 3 letters, and there's very, very heavy books about it. Another hint. Okay. Starts with D. 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 Domain-driven design, yes. AR, it's aggregated root. BC is bounded context. This talk not about it, but the idea is when you do your components, at least make yourself a favor and go read domain design quickly. There is such a book. It's actually only 100 pages long, and it's pretty concise. There are better books. There are more lengthy. They do explain it in more detail, but it helps. And it does take time to get it right. And we argue a lot. We software engineers, we argue a lot about how to do it right. There is no one solution, so don't get discouraged. Okay? If someone else tells you that it's not good enough. So, data isolation. Data isolation we talked before, right? We don't want points of contention. It means that each component is responsible for their own data. What it means? It means if we need something faster or something combined, we might want to replicate data. And that's fine, because it's 2016, and disks are cheap, and replication, when you use the right software, doesn't take 5 minutes. And also, you kind of have to isolate data, otherwise you don't do microservices. So here it is. DevOps, once again, it's step by step it becomes a star of this talk. You won't get your scalability without DevOps, with some Ansible scripts or without some other technology. It's not like I'm in favor of Ansible, but it's the first thing that came to my mind. You have to do DevOps. You have to support them, or you have to do it yourself. Resilience. In resilience, I'm talking about all levels. What does it mean, all levels? So goal is responsiveness, right? Once again, we remember the principles and what it leads to. First of all, we would like to have asynchronous communication. And I'm not talking about asynchronous I/O. I'm talking about asynchronous communication, okay? Any clue or any guess what I meant? Okay, it means that yes, of course, I want my microservices to go by HTTP request, but if I have, for any use case, I'd like to see if I can, instead of going HTTP requesting every time, maybe I can subscribe, and then it will be pushed to me when I need it. So every case by case, if I can use asynchronous communication, I'd use asynchronous communication. Only where I cannot, I will go by more synchronous things. And it doesn't have to do anything with asynchronous I/O. It doesn't matter what kind of server or what kind of operating system you have. It's very important to differentiate. Once again, we have to have our components, because if books, microservices fails, we still want to give results to our users as to toys, pills, and the rest of the stuff, because meanwhile, they might buy something from whatever is working still before it goes down as well. DevOps, once again, you can't have resilience unless you have some DevOps procedure in place if something goes wrong, especially because we are talking about at all levels, right? If components reboots or it has to be moved to some other node, DevOps, that's how you do it. Elasticity, and here it comes. So scalability and elasticity, people tend to use them interchangeably. But it's not true, because that's right that scalability, it's the way how a system could expand dynamically. Elasticity means system could both expand and shrink, right? Now, for having, if you want to serve all your users properly, the minimum that you need to have is scalability. You don't have to have elasticity. It's fine. It's a matter of cost. So elasticity usually is being promoted by cloud providers because it's their bread. That's what they're selling, right? I'm not saying that it's a bad thing. It's a really good thing. It's Earth footprint. It's a cost. There's a lot into it. But it's very important to differentiate it, because it depends on what kind of environment you work in. Sometimes you cannot get elasticity, but it doesn't mean that you cannot have your microservices. You maybe can still get by having scalability. So it's all about cost efficiency rather than anything else. So prerequisite for elasticity is scalability, because you have to be able to expand. And it's either appropriate infrastructure, if we're talking about on-premises, or wise choice of cloud provider, which is really, really important. Not all cloud providers are created same, and you might get a very big headache with working with one of them or some of them. Now, cloud. Cloud, it's not a principle, but I need to put it on a slide and to make it clear, because people tend to say cloud is the principle for my microservices to work. Oh, yet better. I want my microservices to be cloud ready. What it means, It means that I need to make sure that I have my Ansible scripts in my Docker container run on AWS. Not necessarily. It means that I know how to scale it. The rest actually should be provided by cloud provider, right? Now, we all know that there is no cloud. There is something else, computer, and we just usually rent it furnished, and we pay for it as time goes on. So, we said earlier we are talking about umbrella, right? We are talking about, hopefully it's not too small, so probably you can't read the text, but I'll read it for you. So we have all the different colors. We are talking here, all the principles that we talked over. The first coming code isolation, then component isolation, resilience, data isolation, efficient thread model, asynchronous communication, scalability. And elasticity is not there because, once again, elasticity, it's not a principle. It's something that you decide to use, and then you have to have necessary infrastructure for. DevOps supports some of them, and without it, you won't be able to pull it off. Ultimately, with these principles, you'd like to support two things. Two things matter for the technical teams when we're talking about microservices: continuous delivery and responsiveness. And those are two different things, because responsiveness, it's technical, what the metrics are, and continuous delivery, it means code isolation. And code isolation has nothing to do with responsiveness. So as long as I'm paying attention to responsiveness and I forget about continuous delivery, I'm getting a mess because I don't isolate at the code level. I can't stress enough, as you could already see it. Ultimately for your CEO, though, what they're interested in two things. They're interested in user experience, and those are being supported by both continuous delivery and responsiveness, because first we want to serve our clients or our users as fast as we can, and also we want to deliver features as fast as we can. And the second one is cost efficiency, right? So in this slide, we can take, it's very interlaced. And here is the issue, because if we don't have this picture in our mind about interlacing things, if we go one by one, oh, let's do scalability and it will be enough. No, it won't be enough. So, because if you will try to take any of those notions or principles out of this picture, you either responsiveness or your continuous delivery will suffer. Once those suffer, one of the business objectives will suffer as well. So this one is a complete picture as I can see it. We probably will argue, we all software engineers, that what it makes it our profession great. But generally speaking, this is what makes it so hard to navigate in the world of microservices and to go to people who kind of had to move to microservices rather than discovered it because they're more technical, and to argue and to say that's what it is, that's what you need to do. And I think that we, as software engineers and industry in general, we have to move towards notions that short definitions are not always a good thing. Sometimes we need more. Now, the price of skipping will be a chair that doesn't have one leg. Now, I tried actually to come, so I researched a little bit about chairs, and I found out that there are chairs out there, even one with one leg. Now, I think that it's imaginary because I didn't see people sitting on it. I saw they trying to sell it. Also, the chair with two legs, but it usually is attached to the wall. Now, 3, it's okay, but it's kind of custom solution, and 4, which makes it great. So from 3 on, it actually starts working. The more, the better. Exactly the same are microservices. The minimum set of principles, you have to have them, otherwise it will be shaky. The more you add to these principles in terms of implementation and hardening your architecture, the more stable and reliable it will be. Now, the microservices price tag, oh, it's the best. Even people who are bought into idea of microservices, oh, microservice isn't free lunch. Well, monolith is not free lunch either. It also doesn't work anymore. So what's the price tag of microservices? First of all, and it's another little bit hurting idea, but it's something that I think we can get along. we should start design again. Okay? It means that we can say, okay, we will build it, and then we'll make it better, and then we will make it better. That's fine. I'm not against iteration. But we have to have a little bit of design up front now, and there is nothing new under the sun. So it's another iteration of what we had before Agile came on. It's not against Agile. It's just in favor of designing systems before you build them. Doesn't have to be 6 months of waterfall design process, though. This one? No, no, no. Now, we should be also smart. So it means that we can't go and say, okay, you know what, I'll build my thing, and then I'll distribute it. Or I'll build my thing, and then I'll see how asynchronous I can make it, or I can add multi-threading. You can't add after the fact. You need to think about it up front. And if you think that you can live by, okay, it will be fine because the framework that I'm using, it's all about right configuration, good luck. I'll wait you when you'll come to Lightbend to ask for their subscription. We should also consolidate. Consolidate, we need to because we have microservices, it means a lot of nodes. It doesn't matter whether it's Docker container or VM server or physical server, what's not. We have to consolidate all the things because we have many, many, many different places where it can be. Monitoring, logging, all this stuff. Now, when I say consolidate, of course, I don't mean databases, just to make this point clear. We also should support DevOps. So if you go and search online why my microservices failed, you'll quickly find out that majority of these links will say we either didn't have the DevOps in place or we did it poorly. So DevOps, it's absolutely, that's why I consider it as a core principle, kind of, for microservices. If you don't see yourself doing a good job in DevOps, it's not going to work. Just rethink what you need to do or your attitude to DevOps. We are talking about deployment. We are talking about cluster management. Of course, just one thing important to mention, it will be very, very hard, if not impossible, if not right technologies are in place. So once again, everything I'm getting to the right choice of tools, and not only by me being a Lightbend. If you choose your technology wrong, it's going to bite you. If you choose it right, you're going to love it and it's going to love you back. It's especially important with microservices. Now, debugging with microservices is hard because it's a distributed system. I'm saying it's not hard, it's just different. Having said that, we need the right tools in place. Because if we don't have this consolidated logging or consolidating monitoring, then it might be hard. So right tools with the right approach will do the thing. Catch your things before they happen. So we come to the choice of tools. Now I actually have two options. The first option, I can go and take Lightbend technologies and compare them to some other technologies that right now exist. And of course, slam the technologies that do exist because Lightbend is the best. But I won't do it. Instead of it, I want say that what I believe in. Okay, so so by playing this video, I try to understand how many people heard about Lagom, the new Lightbend opinionated microservices framework. As I can see, it doesn't work as well because not many people heard about it. But I intentionally put Lagom, and by the way, it's actually, I think it's a song in Swedish about Lagom. So, but I didn't get this guy actually say Lagom, but whatever. But the idea is that instead of, once again, to have any kind of comparison, I will give you a rule that I've noticed so far, and no one could break it otherwise. The rule is you have to choose your tools, and they should not break any principle mentioned before. Okay? That's it. It's as easy, right? I have my checklist. I have scalability. I have elasticity if I need it, blah, 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 blah. Just check, 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 check. Now, the hard part is it's actually to get through marketing crap. I know. But we are software engineers, so we go right away to development part of the website and trying to get by it. And it is my advice just to go to development part of the website and don't listen to marketing. Just try to see if the tool is actually repackaged crap from 10 years ago or it's a tool that does the job. Now, regardless of what I said, I think it will be valuable for you even if you don't think to use opinionated or whatever microservices framework soon, or you're totally bought on Akka as I am. Take a look at the logon, because the principles and the opinions we actually, that actually is being implemented upon it, those opinions are being based on those principles. So even if you choose or decide not to use Lagom, at least you'll have a good base to see how others decide to implement according to the principles and according to the checklist that I just showed. Well, it concludes the talk today, and I guess we have maybe another couple of minutes to take questions. I'm not sure about time. I always take it late, so I never know for sure. Yes, please.
So when you mentioned consolidating a bunch of things, how do you feel about, for example, people who want to have a polyglot stack as opposed to using the same languages in multiple services?
Oh, no, when I said consolidating, I wish I could mean that everyone should use Scala and Akka. I didn't mean that. What I meant, though, that you can have your microservices, each one of them based on some technology that you decide to. But consolidation should take place at more the DevOps layer. So anything that related to all the scenarios that before that you would go to the specific server, some SSH, some CLI, and you're taking your logs. Now you can't allow yourself to do it because more often than not, you don't know where to log in. So anything that was manual before, or you could get by having it still manual, you can't let yourself anymore. Logging, monitoring, all the facilities around, cluster management, all this should be dynamic with preferably nice dashboards, but at least good CLI options. That's what I meant. Yes?
You talked about code isolation and just not doing it. I mean, always isolating your code. How do you do that? What do you guys do?
So you don't share. It's very hard. I mean, it's actually, so it results in some things that we really don't like. It means that we have to sometimes to write some code twice. And here is the thing. If you are a mass library, right? Like if your application is actually very heavily mass-based and you don't want to replicate code for your functions, then isolate your code into library and version it. And that's right that we all love multiple project kind of, multiple project build.sbt kind of thing. But in this case, you'd better, when you come first thing in the morning, you don't want to spend your first 2 hours by trying to merge. Okay? You want to merge as frequent, but on your terms rather than on someone else's terms. So if you absolutely must have something shared, do it as a library and version. But usually, more often than not, you don't have to share. You don't share things that actually domain knowledge, right? Because the idea of the microservices is that for each service, you have your domain knowledge, and there is nothing to be shared. And if you think you need shared, rethink twice, because maybe you just didn't do it correctly, and actually you have a leak between domain models. That's the idea. Don't share. It's hurtful. I know. Yeah. Anyone else? Okay, thank you very much.